Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back to work over on the steam Stoker engine, and I'm still working on getting together a little fixture to hold the crossheads while we re-pour Babbitt blocks in the bottom for these to slide properly in the little slots that they slide in. Now, if you've been following along with this project, you know that I've already created a new shaft to hold this. We can turn a taper on it that fits up onto the crosshead. And today what I want to do is go ahead and get these aluminum discs where they will fit up into the cylinders here. So if you look, we've got this shaft coming out right now. And what I want to do is make two cylinders. We'll have a hole that will slide up over this shaft, and I'll turn the outside diameter so that they just fit inside these cylinders. And we'll be using these to kind of fixture this to hold it where that shaft is directly in the center of where the piston is going to be running. It's going to be very important because that shaft has got to be parallel to the pistons in all directions. So making these little spacers, these little discs to kind of properly center that shaft should do the trick. So I've got some 1-inch thick aluminum, a little bit larger diameter than what we need. We're going to take these over to the lathe, put a hole in them, bore it out where it'll just fit up over that shaft, and then we will put that on a mandrel, turn this outside diameter to just fit up inside the cylinders. So that's what we're going to do. Let's get her done. First thing I want to do here is figure out what size the shaft is so that we'll know what we need to drill those holes out for. And looks like that is 1.5 inches. So we'll get that done. Let's go to the lathe and get those holes put in there. So first thing I want to do is flip my jaws around on the chuck here so that we can grip this this aluminum disc on the outside diameter. That's the nice thing about this particular chuck is that I do have the reversible jaws in here that you can just flip over, and when you do, you can grip on the outside diameter of larger diameter pieces. So something like this, perfect application. Let me get all these flipped around and we'll get this piece of aluminum chucked up in here and get that hole drilled in there. All right, now that I got all those turned out, we will open this up and we'll just grip it in there. The nice thing about this is I got that nice flat surface on the back side to put that up against. That should be running nice and square. And I think what I'll start by is just facing that surface, and then we'll put a hole in it. All right, we'll just let that face across. All right. Got one little spot out here on the edge that didn't quite clean up, but I'm not worried about that for what we're doing. Let's go ahead and get set up. We'll put a hole in there. A little hole here in the center to get started on. We'll just put a little dimple in there to get that drill bit lined up on. We'll start with a 1/2-inch drill bit. We'll just drill right through there. Slow down the speed of my part here. We're going up to a 1-inch drill now. All right, we're going up another size here. This is 1 31/64, which is just one size up underneath 1.5 inches. So it's really close to our final size. All right, 1.5 inch reamer here. I'm gonna put a little lube on this. We'll just use WD-40, which works pretty good on aluminum. Oops. And we'll take that to final size. I think we got it. The next step is I need to turn the outside diameters of those discs to the proper diameter. And to do that, I need to have a mandrel to check these up on, or to mount them on, so that we can make that outside diameter match the inside diameter. So I've just got a piece of stock here, and we're just going to make a custom mandrel fit this. It'll be 1.5 inch diameter collar, and then we're going to thread a bolt up on the end, or nut up on the end rather, to tighten it up against there. And I'm going to have to figure out what size nut I've got in the shop, and I'll look at that in a minute. But first, let's go ahead and get the 1.5 inch shoulder, or 1.5 inch diameter 2A shoulder cut in here that the disc will fit up on. I'm going to start by facing the end. We'll put a center in this just for some support. Raise that cutter up just ever so slightly. Put the center in the end here for our live center to go up onto and to. Just give some support on the end. And we'll put our center in there to support. Touch off. Let's cut back and make a shoulder that we can put that disc up on. Check this diameter. Looks like we're at 543, 1 inch 543. Put that in a digital readout, 1.543, and we're going to 1.500. Let's try this out. Yeah, it's a little snug, but it'll fit up on there. Well, I missed some of the action there, but we got that turned down to 1.25 inches, down to a shoulder here, where we can slide that up over here. I need to set up for threading now. That's going to be threaded to 1.25 inches 7. I think we're ready to go here. Let's get a number to come around. Whoops, I missed it. Go. I'm going to cut 7 threads per inch, pretty coarse feed. I'm going to come in and I'm going to actually, instead of pulling out there, I'm going to let it cut all the way around because I need that bolt to go pretty much right up that shoulder. We'll back out, come in, and make another pass. I'm going to put some cutting oil on here. Making sure that's 7, it is. I'm going to check my thread. I think I'm going to probably need to take this a little bit more, but we'll see where we're at here. I've got a nut that I salvaged off that Stoker engine, and a little tight. We'll just probably need another pass. We'll take another 5/1000ths and probably do a spring pass after that, and I think we'll be where we need to be. So let me come in, we'll take another 5. Just for good measure, we'll take a spring pass. So I'm not feeding in this time. And it's not cutting much, but it'll clean up any irregularities in there. All right, let's try that. All right, let's try this out. We got our disc here. It's gonna slide up on here. All right, and we got our nut. That'll tighten that up in place. And there we go. Now we can turn that outside diameter, and that'll be concentric to the inside. So let me go get my measurements on the OD, and we'll get these turned out. So up next, what I need to do is I need to come in here and get a good measurement on the diameter of the bores on these cylinders. Now, sometime back, we took the cylinder up to Brian Block's shop up in Kentucky and used his horizontal boring mill and actually bored out these cylinders to get them to a uniform size and within spec according to the book that we have, the manual here with the specs and stuff in it on the cylinders or on this whole engine. Originally, these came with 7-inch diameter bores. According to the specifications, it says that as they become worn, when the cylinders become worn, that you could actually order, back then, obviously you can't anymore, but you could order back then oversized rings, and they made them in 3 different sizes for a 7 1/32, 7 1/16, and 7 1/8 inch bore. So as the engine was used, they would get oversized, and then you just put in larger rings to account for the wear. And then it says that if the wear gets to 7 3/16, that then you should bore everything out and put a bushing in here to get it back down to the 7-inch diameter. These are the original bores. They were worn. I don't remember what they were. I do remember they were pretty badly pitted. And basically what we did is we started boring these out, and we just went to the nominal size that was closest where everything cleaned up. And I honestly don't remember what that measurement was. I want to say we ended up at 7 1/16 inch, which would be 7.0625. So I think is where we ended up at on these. So when we do this, we will make a oversized rings for it. I've actually got the dimensions on the piston here, and you could actually get oversized pistons as well. I'm going to be making new pistons. We may actually make our pistons a little bit oversized to kind of take up for that account as well. So to measure these, I'm going to use a Brown & Sharp bore micrometer, or Intermic as they called them. That was their brand name. Some people call them a tri-mic. I actually just recently picked this one up on eBay because I knew I had this job coming up. This one measures a bore between 7 and 8 inches. I got a good deal on this one. It's been used, but I checked it out, and it is in calibration. Basically, I checked it out on a certified ring, and we checked it out, and it was within half a thou, less than half a thou. So I'm happy with that. You basically use this, you just put it up into the bore, and when you turn the micrometer handle, all 3 of these will kind of move out, and you get it until it fits just right. This is a really good way to check a bore because you're actually measuring in 3 points rather than trying to measure straight across. It just gives you a little bit more of a solid feel and a little bit better. So Let's just check it out. I'm going to stick this up in here. I got it on 7 inches right now. And let's see where we end up at. So, see, that's 7 inches right there. 7.025, 7.050. It's starting to get tight. I got to kind of wiggle it around a little bit. All right, so I'm measuring 7.060. So that's right there at that 1/16 inch mark. And let's measure the other one. That's 7.060. It's about a 0.5 thousandths bigger. So I'm going to still call that 7.060. So that lets me know I'm going to turn those diameters just a little bit smaller than that so they'll slide up in there, probably about 2 thousandths undersize. And we'll go to the lathe and do that. All right, we're ready to go ahead and start turning these diameters. I'm just going to touch off on this. And we'll turn it until it crews up. Get a good measurement, and then we'll get it down to the measurement that we want. All right, we are at 478. 7-inch 478. I'll put that in my digital readout. 7.478. We're going to 7.058. I'm just doing about 40 thousandths at a time. This piece is not keyed on that shaft, so there's a lot of forces at play here, so I want to kind of just take light passes so that it doesn't slip. It's just being held on by friction right now. So we'll just take our time, get down. I can see we're going to have fun with the chips. Probably the reason why I hate turning aluminum. I'm going to verify my diameter here. I changed that feed rate and slowed it down from the first pass. All right, we're at 425, 35, 36, 37, 437. Yep, we're good on the digital readout. All right, I'm gonna just turn it down. I can bring you guys back in a little bit. All right, this should be the last pass. I'm just gonna dial in my number here. 058. Let's see where we end up at. I'm going to get out my micrometer here. We'll check that measurement out. That's 58. So I think that's going to be good. Let me change that. We'll break those edges. Get this inside while I'm at it. All right, I think we're good to go. That one there is finished. I'm going to do the same thing on the other one. Get it turned down, and we'll go try it out. Got my 2 discs cut here. And let's see. up in there. I'll slide all the way forward. And I got my shaft up in there. Let's see if I can get my shaft come through that hole. Oh yeah. And I've got my second piece over here. Come on, there he goes. There we go. So that should hold that shaft in there. Index it where we want it to be, and we can hang our crosshead off the other side and get it properly indexed. This shaft is now running in the exact center of this bore, and that's where we need it to be aligned properly for the crosshead. So this is just for alignment for us to pour that babbitt. Now just looking in the back side here, I'll slide that in just a little bit. Our crosshead should fit right up on that taper. And that should be in the proper position. All right, I like it. So I think we are about ready to pour the babbitt. That's going to be the next video that we do, and what we'll do is we'll melt this babbitt off of the block down here. I'm going to have to put some dams in here on the front and the back to hold it in, and then we will literally just pour the babbitt right into that cavity, heat everything up, and hopefully have what we need. So making progress. Moving forward here on the Stoker engine project, like I said, we are getting ready here next to pour this babbitt in here. That'll be coming up here real soon. Hope you're enjoying this project. This is quite a complex operation, as you can see. Literally a lot of moving parts. And we got to make sure everything is done right on this to make it work out. So with that, we're going to sign off. As always, thanks for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. Big, huge thank you to those who support the site financially through Patreon, PayPal, and now through YouTube memberships. You can actually join up and help contribute there through YouTube. Just hit that join button. And with that, guys, we're going to sign off. We'll catch you on the next video. Again, as always, thanks for watching.